Alright, so this is going to be a quick video on green hydrogen. Now, I realized I did make a little mistake, missed out on a small bit of detail that I'm going to fix up right now. Okay, so in class what we said is green hydrogen is hydrogen gas that can be produced using a renewable source of energy and a renewable feedstock. So what that means is the energy, okay, and the material are both renewable. So if that's the case, then your hydrogen will be green rather than gray, for example. Okay, green meaning it's just very renewable. It's the best type of hydrogen that we can make. Okay, best for the environment. Now, green hydrogen is can be produced in several ways, okay, but these are like the two ways that Vika likes to assess you on, okay? So number one is the one that we're all familiar with, which is this thing called the PEM electrolyzer, yeah? The proton exchange membrane, or it has different names, but yeah, let's just call it the proton exchange membrane electrolyzer. And what it is, okay, this is what I've been teaching you in class, is you use a renewable source of energy like the sun or the wind, and that's correct, you specifically mentioned those things, okay, solar energy and wind power. Now that energy is converted into electrical energy, okay. There is this intermediate, okay, so from the wind, the power of the wind, it gets converted into electricity, all right, and it goes to a battery. Or from the sun's energy hits a solar panel, and then that solar panel will convert the sun's energy into electrical energy, and so then that gives you a power source, right? So it goes to like a battery, a power source, and then that power source is going to drive the electrolysis of water, right? And this is the familiar setup that we know of, okay, where you have a chamber here. This is the anode chamber, and this is the cathode chamber. And the details of how this works, I'm not going to go through in this video. All right, but what happens is the water undergoes oxidation. So this is the anode, okay, and this is the cathode. So anode is positive in electrolysis. So this is the anode right here. So it forces the water to oxidize, and it forces the water to become O2, okay. And then the hydrogen ions are sent across this membrane, and they are reduced down to H2, H2 gas. Okay, so the electrons flow this way, okay, and H2 gas is produced. Okay, so this is what we've known, and this is what I've taught you. Okay, and in this case, what we need to know is that sunlight is converted into electricity first. Okay, so there is a conversion first. All right. Now, what I told you then was, and this is the mistake that I made, was that artificial photosynthesis is the same thing. It's not. Okay. It's not. So what artificial photosynthesis is, and I want you guys to pay attention here. Okay, this is the distinction. What it is, okay, is you take sunlight, and that sunlight is going to go onto some sort of thing that we make, okay? I'm going to call it an artificial leaf. So just like a plant can photosynthesize, right? It takes the sunlight's energy and it causes, and the plants use it to photosynthesize, right? To convert CO2 and H2O into oxygen and glucose, right? Here, what it's doing is it's directly converting the H2O, is directly splitting H2O into O2 and H2, okay? So it's called artificial photosynthesis because there is no intermediate. What I'm saying is that sunlight is directly used to initiate the reaction. There is no conversion to electricity. This is the key distinction right here. Okay, In a regular electrolysis setup to make green hydrogen, right, you have this renewable source of energy that's first converted into electricity, and then that electricity is used to power the electrolysis. Okay, but over here in artificial photosynthesis, we get rid of that step, the conversion step. We make a plant, we make a leaf that can harness the solar energy directly, okay, using catalysts. Okay, there are like catalysts in this thing that we make, this artificial leaf, okay, that will, when it reacts with sunlight, will catalyze this reaction, this electrolysis, okay, where H2O breaks down into O2 and H2. Yeah, this equation's not balanced. Okay, so if you want it to be balanced, let's just do that real quick. So it needs to be 2 there and 2 there. Okay. All right. Yeah, and it's not actually a leaf, okay? It's just something man-made. So if you zoom into this artificial thing that we created, okay, or we're trying to create, this is a new technology. We're not, is not very good at the moment. You could say you can't do it on a large scale. You can do it in a lab. Okay, it's still in development, let's call it. So you still have this process, okay, water, this is the overall process. The catalysts inside this artificial leaf that we have created in the lab can initiate the oxidation of H2O. So this is the oxidation reaction of H2O, and it causes the reduction of H plus on the other side. So this is coming from your Edrolo textbook. Okay, textbook. And you can see here that it's the same reaction happens. Okay, it's just that we have this structure, whatever you want to call it. Okay, this structure here that has some random catalysts that we don't need to know about. Okay, but we just need to know that there are catalysts inside this thing that we have made, this light absorbing material artificial leaf. Okay, there is part of this artificial leaf that can conduct H plus. Okay, there is part of it that absorbs sunlight, and then the catalysts in the part that absorbs the sunlight will directly start the reaction. Okay, you can see there's a whole bunch of other catalysts as well. I wonder how expensive this is, all right, with all of these catalysts. So might not be might not be that sustainable because it's so expensive because of all these catalysts. Okay, so yeah, key thing, sorry, just to wrap it up real quick, artificial photosynthesis is when sunlight is directly used to initiate the chemical reaction. There is no conversion to electricity, just like a plant directly uses sunlight to photosynthesize. All right, so that's it for this video. Hopefully that is clear. If it's not clear, please let me know and I will make a follow-up video.